Okay, hello. Today we're going to be talking about quotient rule. So quotient rule governs functions that are written as a rational. So say something like f of x equals 2x squared plus 5x minus 7 over 3x minus 4. This would follow quotient rule because it's written as one function divided by another function. Now, we already know product rule, so it's conceivable that we could rearrange this so that it looks like this and differentiate this way. But every once in a while, it's nice to skip a few steps and not have to deal with this chain rule uh, and just go straight to quotient rule. So quotient rule, it's never mandatory, but it's good to know, and the proof is nice and easy. So what we'll do is just to prove that, we'll conceive of f of x equals some function divided by some other function. And rather than approach it directly, we're going to rewrite this as a product, which means that a of x is now going to be equal to f of x times b of x. So now we can differentiate this line. When we differentiate this line, well, over here we'll get a prime of x, that's the derivative of a. And over here, this is going to force a product rule. So the derivative of the first times the second plus the first times the derivative of the second. So there's our product rule. The thing is, this is the function that we want to isolate. So we'll take a couple steps and we'll isolate that. Nice and straightforward. So we'll go f prime of x, b of x equals a prime of x minus f of x, b prime of x. Then we'll divide and we'll get f prime of x equals a prime of x minus f of x, b prime of x, all over b of x. So this would be it, except for the fact that we now have this f of x written in the derivative. So what we don't want, we don't want that, so we're going to get rid of that. So to do that, we're just going to go back up here and observe that f of x is equal to a of x over b of x. So we'll do a substitution there. So f prime of x equals a prime of x minus, so f of x becomes a of x over b of x times b prime of x over b of x. So this is sort of ugly, so we can manipulate this a little bit. What we're going to do is we're going to have a common denominator here. Well, that's what we'll do first, and then we'll see what happens from there. So f prime of x is going to equal a prime of x, b of x minus a of x, b prime of x, all over b of x. Now that was just our common denominator. We still have this over b of x all the way down here. So what we're going to do is we're going to take this down here, we're going to invert and multiply. And when we invert and multiply, it'll appear over here as a 1 over b of x. So if we get rid of that, then we'll have this b of x times that b of x. That'll give us b squared of x, or b of x squared. So we'll get a prime of x, b of x minus a of x, b prime of x, all over b of x squared. So what we have now is our final step. This is quotient rule. And quotient rule is what we do is we have, if we refer back to our original function, we have a function on top and we have a function in the bottom. And quotient rule says, take the derivative of the top, multiply it by the bottom as it appears, minus the original top times the derivative of the bottom, all over the bottom squared. So it's that's the way quotient rule works. Now what we'll do is we'll just revisit our original example for just to show you how it works. And that the original example was 2x squared plus 5x minus 7 over 3x minus 4. So according to our proof, that's going to be A, that's going to be B. So when we take our derivative, we end up with, let's run this first, we end up with the derivative of the numerator, which is 4x plus 5, times the denominator 3x minus 4 minus, let's extend that, the original numerator. Now I'm going to put brackets there just because I want to make sure that this negative always gets distributed properly. 2x squared plus 5x minus 7 times the derivative of the denominator, which is 3, all over 3x minus 4 squared. Now, I'm just going to leave that alone. There are more manipulations we could do with this, but that is how the derivative is done. Anything that we would do beyond that is extra. So now we have a proof, and we have an example in action. Thank you.